Understanding third law of motion with an experiment. The procedure is quite simple. Make arrangements as shown in the picture. So what is that we are looking at? We have two toy cars, car 1 and car 2. So it's very important for us to note that the mass of both the cars are one and the same. This is something that you guys have to keep in mind. These two toy cars are attached with the help of a rubber band. The rubber band is over here. Okay, can you see that? Over here. Actually, it's over there. I just marked underneath that. And we have a scale that is running on the sides to help us measure the distance. Right? Okay. What is the step? What are the steps? So we are looking at holding one car at a place and pulling the other car to a distance of 50 centimeter away from the first car and letting go. That is, I'll be holding car 2 in place and I'll pull car 1 to a distance of 50 centimeter. And I'll just let both of them go at the same time. I'm not holding anything, I'm letting both of them go. Observe where the cars collide. You guys have to make an observation where they collide. That is, at what distance they collide. Repeat step 2 and 3, that is this 2 steps, by pulling the car to 60 and 70 centimeter apart. Right? So we have the first car that is to be held in place, second car that is held in place at 0. The first car is pulled to a distance of 50, then another to a distance of 60 and another case to a distance of 70. Right? To help us with this experiment, I have pre-drawn few things. So this distance happens to be 30, 25 and 35. So now, keeping all of this in mind, please watch this video. So what is that we are looking at? In each of this case, when we pulled say to a distance of 50, both of them came to a point of 25. That is the midpoint, right? The center of wherever they were. When I pulled to a distance of 60, both of them came to the point of 30. When I pulled them to a distance of 70, both of them came and collided around 35. So what is that we observed? We observed that all the three cases the cars collided at the center of the path connecting them, is it not? The midpoint, basically, approximately the midpoint. So what can we conclude? Even though we pulled one car, I held one car but I was pulling the other car. While holding the other car, both moved. End of it, both moved. That is, force never occurs singly. That is, there's no single force. If I apply a force, I'll also feel the force. So if you hit someone, you will also feel the force, is it not? If you hit a wall, if you punch a wall, you are the one who is actually doing the action, but you will also feel the force. Right? That's what we are trying to talk about. Force never occurs singly, but always in pairs, as a result of the action between the two bodies. So whoever can be the cause of it, but it's felt by both the sets of objects. If you hit a wall, the wall will feel the force and you also will feel the force. Right? So even though one of the toy car is being pulled and the other car is held in place, end of it, when I do let them go, what happens? Because of the rubber band, they get pulled, but they'll get pulled with equal force. And that is your third law of motion. For every action, there's an equal and opposite reaction. Does it make sense? I hope this experiment made sense. This is going to be useful for the next chapter as well. Right? So to understand few concepts, this is going to be used. Anyways, this is very commonsensical. All the three laws are commonsensical. You should understand and use all of this when you try to understand any physical aspect of anything. Okay, so please pause, do have a look and make a note, running note of your own.